Hello everybody, welcome to the I Am IT YouTube channel. My name is Shabazz Dan. As ever, I am the IT Geek. Welcome back to we're continuing with the AZ700 Designing and Implementing Microsoft Azure Network Solutions Study Guide. So we're going through all the topics in the exam. We are deep into Module 2 obviously right now, and specifically we're on the name resolution topic. As you've probably seen, I've been doing a lot of the theory, and my good colleague, a good friend of mine as well, Mohammed Sajid, has been covering all the demos, and you can follow those demos along. So we'll have Saj with us shortly, and I'll hand over to him to show you that demo. But for now, let's crack on with some theory first. So as I mentioned, we are deep into the module 2, which is designing and implementing core network infrastructure solution, and designing and implementing name resolution part 2 today. So we're going to talk about designing private DNS. We're then going to talk about designing and configuring public or private DNS. And then we'll talk about linking a private DNS zone to a VNet. So what I'm not going to do is I'm not going to cover the topic of configuring public or private DNS. That's what Sad is going to do in the demo. So which is, as I mentioned, he's going to cover shortly. So let's start with the first sort of topic, which is designing a private DNS zone. So Azure Private DNS provides a reliable, secure DNS service to manage and resolve domain names in a virtual network without the need to add like a custom DNS zone. By using private DNS zones, you can use your own custom domain names rather than Azure provided names available today. The records that are contained in a private DNS zone aren't resolvable domain. They're not resolvable from the internet. So DNS resolution against a private DNS zone works only from virtual networks that are linked to that DNS zone. Okay. You can link a private DNS zone to one or more virtual networks by creating virtual network links, and we are going to be talking about that later as well. Sticking on this topic of sort of private DNS zone, private DNS zone does have some restrictions, multiple in fact. So single label private DNS zones aren't supported. Your private DNS zone must have 2 or more labels. So, for example, IamITgeek.com has 2 labels separated by a dot. A private DNS zone can have a maximum of 34 labels. You can't create zone delegation or NS records in a private DNS zone. If you intend to use a child domain, you can directly create the child domain as a private DNS zone. Then you can link to that virtual network without setting up a name server delegation from your parent zone. And I believe it was as of August 2022, so last year, specific reserved zone names were blocked from creation to prevent disruption of services. So I just want to talk about linking a private DNS zone to a VNet. Then I'll hand over to Saj to do the demo. So linking a DNS zone to a VNet allows VMs hosted in Azure Virtual Networks to access private DNS zones. So every private DNS zone has a collection of virtual network linked child resources. Each one of these resources represents a connection to a virtual network. When you create that link between the private DNS zone and that virtual network, you have the option to enable auto registration. And with this setting enabled, the virtual network becomes a registration virtual network for the private DNS zone. So a DNS record gets automatically created for any virtual network, any virtual machine you deploy in that virtual network. So DNS records will also be created for virtual machines already deployed in that virtual network. If you choose to link your virtual network with the private DNS zone without auto registration, the virtual network is treated as a resolution virtual network only. So these records for the virtual machines deployed with this network won't be created automatically in that private zone. However, virtual machines deployed in the virtual network can successfully query DNS records in that private DNS zone. So some light topics there. I think that the important bit is the demos here. So I'm going to hand over to Saj to go through creating a public and a private DNS zone. So over to you, Saj.
Thank you, Shabazz. Shabazz has just gone over private DNS zones. So in this demo, we're going to look at private DNS zones and some of its capability. So to create a private DNS zone, just search for private DNS. and select private DNS zones, and then select create. Select your subscription. Again, we're using the Am IT Geek subscription. We'll use our AZ700 test resource group, and we'll use a test domain we used previously, sajidm.co.uk. And I've already pre-created this because it takes a little while to deploy, and I didn't want to keep the video waiting. But if you're happy to go ahead with your domain, just change to .com. Let's go next. So review if using tags. If you're happy, review what you defined within creating the page, and then select create. Wait a while, and you'll end up with a private DNS zone. At this moment in time, it isn't really doing anything. By default, you only end up with an SOA created. This is the old registration that exists when you create it by default. What we've done here is under settings, go to virtual networks, and we've linked the private DNS zone to a virtual network. The VNet that we linked it to is VNet 02. So to create that, select add link name. You can call this whatever you want. So AZ700 demo link, that's the name, and then the subscription, and then the VNet that you want to link it to. So we linked it to VNet 02. Select the VNet you want to link it to, for example, and select enable auto registration. And what an auto registration does is when you create a resource in that, like a VM with the IP address, it will auto register within your private DNS. When you delete it, it will remove that entry dynamically. Select enable, and once you're happy with the settings, select OK. Wait a little while, and it will create that for you. And as you can see here, it has 2 entries for 2 VMs that we already deployed. Because they already existed, once we enabled auto registration, it looked at the VMs that existed within that VNet and has created the A records for those 2 VMs. These are automatically registered. Now, being DNS, you can create other records. So if you want to create new records, just select record set. And as we saw previously, the domain that we're creating is for internally. The DNS is sajidm.co.uk. And you can create A records, IPv6 A records, MX records, pointer records, text records, service records. So create the record set that you need for your requirements, define the TTL and the IP address. Now, if we just create one, for example, so if we call this test AZ700 demo 0.05 as an example. So this is a test, and it gives an IP address on that isn't in use, 10.2.0, 10.2.0.9. We create this record, you'll see that it creates a manual entry for you for the server if it existed. TAZ700 demo 05 is an A record. TTL was left to default, but as you can see, auto registration is false. So to demonstrate this, if you had a server as an example here on the virtual machines at 05 and you delete that server, because this is set to false, this record will stay as it is. So what we can do is update one of these records here just to demonstrate that. So if we go to our record set and we create a new one, T-AZ700 demo 03, we'll give it an IP address of 10.2.0.5. So we're matching the dynamically created entry here, the auto register entry, with a manual entry 10.2.0.5, which is the actual IP address of the server, TAZ700 demo 03. So if we select that, once it's created, the auto register entry disappears and you end up with a manual created entry, which is auto register set to false. As we mentioned before with this one, you would have to, if you then came in here and you deleted your server, if it exists, refresh, where's our server, 03. So you select your 03 server and you actually deleted this server. This will take a little while. We'll come back and check what happens to the entry. You can create entries in here dynamically or auto register, and if you need to delete one manually, you can just select the one that you want to delete. So we created the TAZ700 demo 05 A record. So if you want to delete an A record, just delete an A record or any other entry that you created in here by selecting the record and selecting it and confirm. So once that's done, we've manually deleted this record. So if we check back on our server to see if it's been deleted, this process is taking a little while. What should happen is the server's now been deleted. The command has been executed successfully. We don't have a 03 server. If you come back to our private DNS zone, you see the entry still here. If you refresh, the entry for that server doesn't disappear because it was a manually created entry, not a registered entry. It still exists. So to delete that entry, you would need to select the entry that you want to delete and delete it. So just to quickly recap, if you enable auto registration when you associate your private DNS with your virtual networks, any resources that already exist or any resources that you create will have a record created in here dynamically. And if you deleted any of those resources, it will delete that entry for you dynamically. Anything manually created will not be deleted dynamically. In this lab, we're going to look at creating a public DNS zone for a test domain that we have. So there's 3 elements to this I need to look at: creating the DNS zone, configuring the DNS zone, and then updating the settings that you registrar to point to the name servers of Azure's DNS zones, Azure's name servers. So just to step through the whole lab, to show you everything that's been pre-staged to make this lab work okay, what I've done is within Azure, I've created a virtual machine, Windows Server 2019, in our task AZ700 resource group, and the machine's been created with both a private IP address and a public IP address. And then once you connect to the machine, I've installed IIS web servers on this. Nothing special, just selected all the default settings, and just to step through that process for you. Run Server Manager, go to Add Roles and Features. On the Before You Begin page, select Next a few more times, and then you want to install Web Server IIS. As part of this demo, I've just installed all the default features, press Next a few more times, and then once it gets to the end, select Finish and wait. It takes a little while, and it creates a default website for you. So if you open Internet Explorer and type in localhost, you should get the default website. There you go, Internet Explorer. So basic web server running on this particular server. It has a public IP address of 172.168.193.201. The next step is to deploy and configure the DNS zones. So to deploy a configure a DNS zone, just type in DNS and select DNS zones, and then select create. It's simple options, because this will just deploy one for you, but there's nothing configured at this stage. You get a couple of default records created, and we'll take a look at that. So in our example, we're deploying it to the Am IT Geek subscription, our AZ700 test resource group. There's an option here. This zone is a child of an existing zone already hosting Azure DNS, which it isn't, so that's not selected. And the domain that I'm using as part of this demo is sajidm.co.uk. As it already exists, it won't let me create it. And just to step forward from this, just select .com. UK South is where everything's been created as part of this demo. Select next. If you're using tags, define your tags here. On the review and create page, review everything you've defined. If you're happy, select create. Wait a few moments, and you'll end up with a deploy DNS zone, sajidm.co.uk. And if you look at the overview page, you end up with a few default records, name server records, and they're all Azure dns.com.net.org.info, and the SOA records are deployed by default. So what we've done is we've created a record pointing to the public IP address of the web server that we deployed, which is 172.187.193.201. And we can verify that IP address by going back to the web server itself, virtual machines, and in the overview section, you see a public IP address of 172.187.193.201. To create a DNS record, select record set. And here, because we're using sajidm.co.uk, just define at for that particular domain, the record that we're creating already exists, what the error is telling me there. So if you look at the type of record, you can create an alias record, which is what we've created in IPv4. You can create an alias IPv6 record, certificate authority record, a CNAME record, an MX exchange record, name server record, text record. So the type of record that you need, you can define here. In my demo, it says 300 for TTL. So what I've done is I've lowered the TTL to 5 minutes. So select the TTL that you require. Default is 1 hour. For the demo, I didn't want it to be 1 hour. So for the refresh, so I've just changed it to 5 minutes and then just define the IP address. So the server IP address is 172.187.193.201. Now when you're happy, select OK. It will wait a few moments. It will create a record for you. So at this stage, you've deployed a DNS server. You've created a record that you need, but it's actually not doing anything. You need to change the name servers at your registrar and to make sure that these name servers, the Azure name servers where your record exists, are being used. So to do that, you need to go to your registrar. In my case, it's 123reg. Go to the name server management tab. It'll be slightly different for different providers. And then update the name server. So if you see here, I've updated the records to azuredns.com, dns.net, dns.org, dns.info. You can see here it says it can take up to 48 hours for name servers to update across the internet. So propagation will take time. So in my case, you copy and paste from Azure portal, the web portal, to the name for servers here, select update and wait a while. And then once it's been propagated and you're good to go, you can verify that it's actually working. So if you go back to the Azure portal, one of the ways you can verify that this works is by connecting to any shell like PowerShell, the command line, CMD. So we're in Azure, so we just connect to the Azure PowerShell and then use the NS lookup tool. And I've already typed it in before, so just it's NS lookup query type equals name server, and for this website sagidem.co.uk or the domain name sagidem.co.uk, and that gives you the name server records that match Azure. So if we go back to DNS zones and we select our DNS zone, the name server records here now match the name server records that we copied from Azure, dns.com, azuredns.com, net, org.info. The other thing we can do to verify this is if we connect to Internet Explorer again and actually use the domain name instead of the IP address, it should now resolve and give you the same default web page. There you go. So once everything's propagated, it should work for you, and you have a DNS record, a public DNS record created for your domain, in our case, sagidem.co.uk. Thank you for watching. Back to you, Shabazz.
Thanks, Saj. Appreciate that. Thank you. Two really interesting demos there. And I thought, again, rather than talking about public-private DNS zones too much, I'd let Saj take over and actually show you how to do them and how important they are and what we can do with them. So I hope you enjoyed that. So yeah, we are done now with this topic. So the name resolution topic is now done. That was a two-parter. So that we're sticking with module 2 still. We've still got a bit to go on module 2, but we are going to be talking about cross VNet connectivity, which is the 3-part episode. That's 3-part topic. So we're going to be looking at sort of route tables with subnets, talking about implementing NAT gateways, and looking at sort of virtual WANs as well. So some interesting topic coming up. Again, we appreciate everybody's support. You can see the links to the labs in the description. Please do follow those along as Mohammed Sajid is doing them. Links to mine and Sajid's sort of socials, LinkedIn and Twitter. Please, by all means, give us a like, give us a follow, give us a tweet if you've got any questions or comment on the video. Please do like the video, and if you're not subscribed, why? Smash that subscribe button. So thank you everybody for watching, and up until next time, goodbye.